That is metals and non-metals. Easy chapter, which was actually important, that was removed. So actually nothing is left out in this chapter. Much more things are not there, very less part you have, but I will explain you that also. Fine. So metals and non-metals, there are three parts in this chapter. So first part is physical and chemical properties of both. Second one is the ionic bond, the bond between metals and non-metals. Ionic bond, that is a formation of molecule of metal and non-metal. And the third part, extraction of metal. So out of that, you have for this year board exam, you have only first and second. The third part has been removed. Now it is not there. So this is actually the important and somewhat complicated one. Students are facing problem, but now this part is removed. So you are left with only physical, chemical, and ionic bond formation. So we are starting with the physical and chemical properties of metals and non-metals. Starting with the first part, physical properties of metals and non-metals. So in the physical properties that you have learned already, the metals, first tell me what are metals and non-metals means. What do you mean by metal and a non-metal? So whose division, which matter, which type of a matter is divided into metals and non-metals?
Elements.
Elements. So matter divided into pure substance and impure substance. So pure substance, that is the substances which are made up of similar type of particles. So in that, if any pure substance is made up of similar type of atoms only, so exactly all the particles present in the substance is exactly same to each other. That means they are all atoms are present in that matter, in that pure substance. That substance we call as elements. And then elements are divided into four types. So what are those four types? Elements are divided into four types. What are those four?
Metals, non-metals, metalloids.
And the fourth one?
Compounds.
Inert gases.
No.
Inert gases, right. So elements are divided into major four parts. That is, one is metal, second one is non-metal, third one is metalloid, and fourth one is inert gases. So metals and non-metals are separated by their physical as well as chemical properties. So much more visible properties what we can see, and we differentiate those substances. Those are physical properties. Inside this substance, if you go inside, go through the atomic structure, the structure of chemical reactions, if we go through, then the separation also can be done on metals and non-metals part. Visible differences will be seen in metals and non-metals according to chemical properties as well. Then what is metalloid means? What do you mean by metalloid?
It has the property of both metal and non-metal. Some properties of metal and some of non-metal.
The properties intermediate to metal and non-metal. Keep on much more time. I have explained you in the second chapter last year. Told you don't write it is at a has both properties. You have to write that is the properties of the substance which are intermediate between metal and a non-metal. So those are called as metalloids. Examples of metalloids?
Silicon.
Silicon, yes. And germanium. Further. Further. Silicon, germanium, boron, arsenic, polonium. These are all examples of metalloids. And what are inert gases? What do you mean by inert gases?
They do not react with other gases. They have
Gases
completed
only?
a duplet or octet.
Yes, they have completed the duplets or octets and they do not take part in any chemical reactions. So they are chemically inert. So therefore they are called as inert gases. And these are mostly found in the form of gas. So therefore it is called as inert gases. Okay. So further we have to see now metals and non-metals. Physical properties, the difference according to their physical properties. Metals, non-metals. First one is their physical state. Physical state is, for metals, they are you have learned in class 8th itself. Metals are hard, solid. Few exceptions are also there. We'll talk about that. So exceptions I will write further. Metals are hard solids and non-metals are mostly found in gaseous state. Right now, 118 elements are known. Out of that, 85, 86 are metals itself, 16 are non-metals. And the 6 are inert gases and remaining are metalloids. So most common substance on this earth is a metal. So there are exceptions are there also there. So first one, non-metals mostly found in gaseous state. So which non-metals found in gaseous state? Name of the non-metals? Couldn't get? Yes. Bromine is not in gaseous state.
Oxygen.
Oxygen, hydrogen, nitrogen, chlorine, then oxygen, hydrogen, nitrogen, chlorine, iodine is not there, bromine not there, phosphorus, sulfur, no. Then in solid, few liquid state, a single non-metal which is in a liquid state, that is bromine. And some are there in the solid state but are brittle, solid but brittle or in the powdered form. Those are sulfur, carbon, phosphorus, iodine. Iodine crystals are there. Then here the exception for metals, or generally all metals are hard solid, but few exceptions are also there. So what are the exceptions? That is, first one is a liquid metal. What's the name?
Mercury.
Mercury. Sodium and potassium, even lithium, are soft, can be cut with knife. Okay, so these are the exceptions. Now the second property is lustrous. So metals are lustrous and non-metals are non-lustrous. But there are exceptions as well. So here exception. Graphite and iodine. Graphite is a form of carbon. Graphite is a one allotrope of carbon. So allotrope means the substance, any element is found in 2 or 3 different forms. Physical forms are different because of their binding between the atoms is different. But inside that the substance is same. Atoms, it is graphite, diamond are made up of carbon only. So inside that only carbon atom is present. But the binding of carbon is different. binding of the carbon between the graphite and diamond is different. So that's the reason physically they look completely different from each other. But inside that they are all same, that is a carbon itself. And graphite possess somewhat luster and iodine possess most luster. Iodine it is found in the crystal form, but they are lustrous. So here all are lustrous. There is no exceptions. Just a second, I'm coming. For the properties? Yes, any other? Do you remember?
Malleability.
Yes, they are malleable and ductile. Metals are malleable and ductile. Non-metals are non-malleable and non-ductile.
Well, they're good conductors of heat and electricity.
Good conductors of heat and electricity, and these are bad conductors.
Metals are sonorous.
Yes. Metals are sonorous and non-metals are non-sonorous. What do you mean by sonorous? Sonority?
When we
Produces
strike them,
sound.
they produce a bell sound.
Yes, the phenomena in which the metals form the ringing sound when stuck hard with another metal, any object. Then sixth one, they have high melting and boiling points, and these have low melting and boiling points. Non-metals have low melting and low boiling points. But here exception is there again. Metals exception, that is gallium and cesium. Gallium and cesium melt when kept on palm itself, but because its melting point is 29 degrees Celsius, 300 Kelvin it is. Okay, so remember these names. The question is asked for 1 mark. Name the metal which melt when kept on the palm. So that is gallium and cesium are the metals which melt when kept on palm itself, because that much heat energy is enough. Our palms, our body heat is enough for them to melt. Okay, then high density. Yes.
Ma'am, even graphite is a good conductor of electricity, right? So it's like
Yeah. So
exception.
here exception is graphite. Exception is graphite for electricity and diamond for heat. This is for current and diamond is for heat. And here also there is an exception, that diamond. This one, hard solid. Exception is a diamond, hardest substance. So it is harder than metal itself. Metals have high density, non-metals have low density. Then tensile strength.
When they react with oxygen and form basic oxide.
That is chemical property. We are talking about physical property right now. High tensile strength. And this is actually no tensile strength, but we don't write no, so it is low tensile strength. What is tensile strength? What do you mean by tensile strength? No idea. Tension force? Tension. Tension force is created in the string or spring or thread, rope, whenever any load is attached to it. So any rope is connected to a load and try to pull upwards. So to hold that load, there is a tension force is created in the rope which can withhold that load. So that is tension force. So tensile strength comes from that tension force, which can provide more tension force. That is tensile strength. That means a metal, whenever load is applied on that metal, load is connected to the metal without bending, without breaking, they can hold that load without breaking, bending. So that is called as tensile strength. So high tensile strength is present in iron. Iron, that is a reason iron is used in construction of building as well as construction of bridges. So very heavy load is given to the rods of this iron rods which are used for the construction, or over the bridge heavy tons of trucks are moving over that bridge, which is actually the main support is provided by the iron rods. But still iron stand at the same position without bending, or it won't break also. That is because it possesses high tensile strength. It's clear? Are these points clear? Yes, ma'am.
Yes, ma'am.
So write down everything.
Yes, ma'am.
Write down that. So these are the physical differences between metals and non-metals. Completed? Have you finished? Yes, ma'am.
Yes, ma'am.
Everyone done?
Yes, ma'am.
Then next is chemical properties of metals and non-metals. So yeah, before this, write down some important points, the metals. So there, write down sodium, potassium, lithium. Sodium, potassium, lithium, soft, easily cut with knife, kept under kerosene or stored under kerosene. Then silver, Ag, best conductor of heat and electricity. Silver, best conductor of heat and electricity. Then lead and mercury are poor conductors of heat and conductor of heat. Poor conductors of heat. Gallium and cesium. Low melting point. Melt when placed on palm. Phosphorus, stored in water. Then fluorine, most reactive non-metal. Most reactive non-metal is fluorine. Iodine, lustrous. Diamond, hardest metal, hardest non-metal. Actually, hardest substance. Okay. Everything clear? Everything clear to you?
Yes.
Completed?
Yes, ma'am.
Yes, ma'am.
Then chemical properties. In that, first we have to check the reaction with oxygen. Second one is reaction with water. Third one with acid. And fourth one is displacement reactions. So first one is a reaction with oxygen. So metal reacts with oxygen, forms metal oxide. And non-metal react with oxygen to form non-metallic oxide. Okay, so any metal combines with oxygen, it will form metallic oxide. Sodium plus oxygen form sodium oxide. Potassium combines vigorously. So these reactions are vigorous reaction. So these are vigorous. Calcium combines with oxygen, forms. What does it will form?
Calcium oxide.
Calcium oxide. Quicklime. Magnesium burns in oxygen and forms magnesium oxide. Aluminium combines with oxygen, form aluminium oxide. Copper, when heated strongly, get coated with a black color copper oxide. One important property here, all metal oxides are nature of the metal oxides
Basic.
basic in nature. Okay, so all metal oxides are basic in nature. Now non-metal oxides react with oxygen. Carbon reacts with oxygen, forms carbon dioxide plus heat energy. Then hydrogen combines with oxygen in presence of electric current, that is forms water, it will form. Nitrogen combines with oxygen, form nitric oxide. Sulfur combines with oxygen, form sulfur dioxide. So here, these are this way the non-metal oxides are formed. And non-metal oxides are, what is the nature?
Acidic.
All are acidic. Water is acidic.
Acidic and neutral.
Are either acidic or neutral. Which are acidic? Carbon dioxide, nitrogen dioxide, sulfur dioxide, sulfur trioxide. So these are acidic oxides. And neutral oxides are carbon monoxide, water, and nitric oxide. So these are neutral oxides. Okay. Okay, so write down this. Then I need to explain you amphoteric oxides. Are we done? Have we completed?
Yes, ma'am.
Everyone finished?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Amphoteric oxides. Now, what do you mean by amphoteric oxide? This is very important part of the chapter. Now, we have seen that is all metal oxides are basic in nature. But for exception for this, there are some metal oxides which, why we consider metal oxides are basic in nature?
Because they release OH minus ions when dissolved in water.
No. Some of the metal oxides do not dissolve in water. Why? Anyone? We have learned in chapter second chapter.
Because when they react with acids, they produce the salt and the water.
Yes,
It is
exactly.
similar to the reaction between acid and base.
Acids and base, right? So here the formation of a water explains that OH minus ions are given by someone. So who is that someone? Someone is that metal oxide. So whenever metal oxide combines with acid, it gives out water along with the salt also. So formation of water explains that H plus ions comes from acid. Then OH minus, who has given OH minus? Who has donated OH minus ions? That is metal oxide. So therefore metal oxides are basic in nature. Generally metal oxides do not dissolve in water, but still when that OH minus formed when these metal oxides are combining with acid, not with water. So aluminum oxide is not soluble in water, then it cannot produce OH minus ion. So it is only when it combines with acid. So when it is mixed with acid, it is giving out OH minus ions. Acid has water. So along with water and acid, the metal oxides are producing OH minus ions. So therefore they are called basic in nature. But there are few metal oxides. These are basic in nature as they react with acid to form water and salt. Few metal oxides have property to react with both acids and base. Acids as well as base to form salt and water. So this means that it can react with acid, so it is basic in nature, but it combines with base as well. So if metal oxide combined with base, that means which property it shows? Which nature it shows when it combines with basic substance? When metal oxide is reacting with basic substance to form salt and water, so which property does it shows?
Acid.
Its
Acidic.
nature is acidic. That means it has the properties of both acidic as well as basic. So therefore, instead of calling them as either acidic or basic, we call them as amphoteric. This means these oxides show both acidic as well as basic nature. Hence, these oxides are called amphoteric. So those oxides are aluminium oxide, zinc oxide, and lead oxide. Aluminium oxide, zinc oxide, and lead oxide has the property of reacting with both acid as well as base and shows both acidic as well as basic properties. So therefore it is called as, these are called as amphoteric. Clear? So you have to show also, this can be proved by the reactions. So aluminium oxide, when combines with hydrochloric acid, it will form AlCl3 plus H2O. So here this is acid. To form water, it is giving OH minus ions. So therefore it is basic nature here. It shows the basic nature. So here it is. Okay. So this is balanced reaction, as well as now this aluminium oxide has a property of combining with sodium hydroxide as well. So it will form NaAlO2. So what is the name of this? What's the name of this compound?
Sodium aluminate.
Sodium aluminate is a salt and water is formed. So that means here this is a basic substance. So that means it should be acidic in nature. So here it shows acidic nature. And then the similar for the zinc oxide also. So you need to remember both the reactions. Zinc oxide combines with hydrochloric acid. It produces zinc chloride plus water. So it shows here basic nature. And the same zinc oxide combines with sodium hydroxide. Here it will form Na2ZnO2. Name is
Sodium zincate.
sodium zincate. Sodium zincate is formed. And along with lead, it will form lead sodium plumbate. So here it shows acidic behavior. Okay. So this way, amphoteric nature of zinc oxide here and the amphoteric nature of aluminium oxide. Okay. So this part, 2 mark, very important question. Note it down properly. Completed?
Yes, ma'am.
Done? Finished, everyone?
Yes,
Yes, ma'am.
Everyone done?
yes, ma'am.
Okay. Then second is a reaction with water. Metals reacts with water to form either metal hydroxide, few will form hydroxide, and few will form metal oxides. And along with that, hydrogen gas is given out. It's evolved. So which metal form metal hydroxide? Which metals will form metal oxide? So in the reactivity series, first four metals, that is potassium, sodium, calcium, and magnesium. So these will form hydroxide because oxides of these elements are soluble in water. So they immediately dissolve in water and gets converted into hydroxide. And remaining everything, aluminium, zinc, iron, copper won't react, lead will form oxides. Okay, so we have to see all these 7 reactions. So metal, potassium combines with water. It will first form K2O, oxide. It will also form oxide and hydrogen gas. But this oxide, again soluble in water and forms potassium hydroxide. So altogether, it is only written as K plus H2O form KOH plus H2 gas is given out. So this is the total reaction. Actually, it is a two-step reaction, but in your textbook, it is given as a one reaction. So it is 2K plus 2OH2O gives out 2KOH plus H2. Similarly, sodium also combines with water very vigorously and forms sodium hydroxide, and hydrogen gas is evolved out. So these two reactions are very vigorous because these two elements are more reactive elements. So in this case, the evolved hydrogen gas catches fire also. Immediately it will catch fire. And these two can combine with chilled water also. They have the property of combining with chilled water as well. It can combine with the normal water, but it has a property of combining with chilled water also. So that reaction is highly exothermic reaction. This is highly exothermic reaction plus heat because it is very high amount of heat is given out. So that is the reason hydrogen gas catches fire because it reaches its ignition temperature. Then calcium cannot react with chilled water, cold water. It can combine with only the normal room temperature water and form calcium hydroxide and the hydrogen gas is given out. Now it needs a room temperature water. It can't combine with cold water. Okay. Then magnesium, it's a double reaction takes place. Magnesium, if combined with liquid water, but it is a boiling water, warm water, then it will form magnesium hydroxide and the hydrogen gas is given out. But if the same magnesium combines with steam, this is the gaseous state, that means if it combines with steam, then it will form magnesium oxide and the hydrogen gas is given out. Okay, so if it is a combines with liquid water, but it is a boiling or a warm water, then it will form magnesium hydroxide. But if it combines with steam, then it will form oxide. So it will form magnesium oxide and the hydrogen gas will be given out. Is it clear? Dual nature of magnesium?
Yes, ma'am.
Aluminium combines with only high pressure steam. It cannot combine with liquid water. Now it needs steam only. So when the high pressure steam is passed through aluminium, so it will form aluminium oxide and the hydrogen gas is produced. Same thing happened with the iron. Iron first has to be heated to make it red hot. So red color iron has been formed and then only the high pressure steam is passed through it. So it combines only with steam. It cannot combine with the normal water or boiling water. It won't combine with boiling water as well. So it can only, this one, if the high pressure steam is passed through iron, then only the iron combines with water and form Fe3O4 and the hydrogen gas is given out. So now what is Fe3O4? Fe3O4 is a mixture. It is not a compound. It is a mixture of both the oxides of iron, FeO and Fe2O3. So it's a mixture of iron oxide and iron 3 oxide, iron 2 oxide and iron 3 oxide. Both the mixtures is Fe3O4. Are you able to understand? Today you are not 8 or you are not there? I'm not getting a single voice also today. What happened?
Yes, ma'am.
Yes, ma'am. So this reaction, anyhow, you have to remember, this is very important reaction. And then iron onwards, that is copper, silver, gold, mercury, won't react with any kind of water. Copper do not react with any type of water. Any type means any state, liquid, gaseous, nothing. Type of water. Hence it is used in boilers, geysers. Because in boilers it is a good conductor of current also, so it carry current and as well as do not react with water. So therefore it is used in boilers, hot water tanks, geysers, etc. Is this clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Write down. Complete?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Now here important points to note. One, you have written about the copper. This is about the copper. Second one, calcium and magnesium when added to water starts floating. When react with water, start floating. Why? So the reason is for this, these are light metals. When they react with water, form hydrogen gas, bubbles. These bubbles stick to the surface of metal. These bubbles stick to the surface of metals. So therefore, these metals start floating. Clear? Is this point clear? This question can be asked for give reason. 1 mark question. Completed? Yes, ma'am.
Yes, ma'am.
Yes, ma'am.